Good day, friends. Today we will discuss basic trigonometry. Now, before we start on the topic, I'd like to discuss some related concepts that are important for you to know so that when we move forward, you have the basics in hand already. The first basic concept that you need to be aware of is the right-angled triangle. This here is an example of a right-angled triangle. It's a triangle in which one of the angles is equal to 90 degrees. So as you can see, the angle C here is equal to 90 degrees. To keep things easy, what we will assume is that this angle here is angle A, this angle here is angle B, and the 90 degree angle that I just marked is angle C. Now the side opposite angle A, which is the length BC, you mark that with a small a. The side opposite angle B, which is the length AC, will mark that with a small b. And the side opposite 90 degrees, which is also known as the hypotenuse, will mark that as C. The hypotenuse is the longest side of a right triangle, and it is the side opposite the 90 degree angle. The general rule for all triangles is that the side opposite the smallest angle is also the smallest in length. So therefore side length here A will probably have the smallest length because angle A seems to be the smallest angle. Similarly, the side opposite the middle angle, which is angle B here, and this is the side that is opposite the middle angle, will be medium in length. And the side opposite the largest angle here is 90 degrees, and this is the side opposite that has to be the longest side. This rule is true for all triangles, and you need to be aware of this because this is one of the most basic concepts that we will apply in trigonometry. The second important concept in trigonometry is the Pythagoras Theorem, also known as the Pythagorean Theorem. Now this theorem is very important. It states that for any right triangle, the sum of the squares of the two legs of the right triangle is equal to the square of the hypotenuse. Basically, we can write this as a square plus b square is always equal to c square. And remember that all right triangles conform to this rule. It is not possible to violate this rule for any right triangle. And this is very important because it allows us to figure out the length of any third side of a right triangle if we know the other two sides. Now let's learn a basic application of the Pythagorean theorem. Let's say that you have this triangle here, triangle ABC, and the sides are given to us as follows. The side opposite angle A, which is the smallest side, the shortest side, has a length of 3 centimeters, and the side opposite angle B, which is the medium side, has a length of 4 centimeters. And the question wants us to figure out the length of the third side, which is the hypotenuse, which is known as C. Now, to be able to apply the Pythagoras theorem, you need to know two sides of a right triangle. We know these two sides. These are called the legs of the right triangle. So the application is very simple. A square, we know that a square plus b square equals to c square, which means that 3 square plus 4 square should be equal to c square. Now 3 square is 9 and 4 square is 16, should be equal to c square. So we get 25 is equal to c square. So therefore, to find the value of c, we will take the square root of both the sides, and we get c is equal to under root 25, which is equal to 5. So therefore, the length of c is 5. Make sure that you understand this concept before we move forward. Right, I want you to try this concept on your own. Let's say that this side has a length of 5 centimeter and the base has a length of 12 centimeter, and I want you to figure out the value of c, which is the hypotenuse. I want you to hit the pause button and try the question on your own, and then play the replay button so that you can see what the solution is. Okay, I hope you've tried it by now. So the way to apply this is very simple again. We know that a square plus b square is equal to c square. So therefore 5 square plus 12 square should be equal to c square. You'll get 25 plus 144. 144 is equal to c square. 25 plus 144 is 169. So we can say therefore that 169 is equal to c square, and therefore c would be equal to under root 169, which is equal to 13. So that is the length of the hypotenuse, 13 centimeters. I hope the application of the Pythagorean theorem is very clear to you now. Now we'll move on and talk about the application of basic trigonometry. So what's trigonometry? Trigonometry helps us figure out the various ratios of the sides of a right triangle. Now, why is that useful? Let's say you have this right triangle where the angles are marked as 30 degrees, 60 degrees, and 90 degrees. Let's call the smallest angle A, and 60 as B, and the 90-degree angle as angle C. Now, if I were to tell you the length of only one of these sides, would you be able to figure out the length of the other two sides? Well, trigonometry can help you do that. You see, let's say that the side opposite angle A, which is the smallest side, has a length of 10 centimeter. And the question wants you to figure out the length of the other two sides. Now, with the Pythagorean theorem, you needed to know two sides of a right triangle to figure out the third side. Well, with trigonometry, even if you know the length of one of the sides and you know what the angles are, you can figure out what the other two sides are equal to. With this particular triangle, and with our knowledge of trigonometry, we can confidently state that the length of the second side, the medium side, is going to be 10 times under root 3, and the length of the hypotenuse is going to be equal to 20. Now, how did we do that? So let's start our discussion of basic trigonometry. Let's say you have this right triangle as I've made here in front of you, with the angles capital A, capital B, and capital C, and the side lengths with small a and small b and small c. Now let's mark this angle A and call it theta, which is a Greek letter, and we usually use theta to refer to angles in trigonometry. Theta is spelled as T-H-E-T-A. Now, as you can see, we have these three side lengths, A, B, and C. And we can find the ratios between them. For example, we can find the ratio between A and C. Let's write this as A upon C. We can find the ratio between B and C. Let's write this as B upon C. And we can find the ratio between A and B. Let's write this as A upon B. Now these three ratios that I've created, they have a name. The first one, A upon C, is known as sine theta. The second one that I've created, B upon C, is called cos theta, which is short for cosine, or C-O-S-I-N-E. And the last one that I've created, A upon B, can be written as tan theta. So these three ratios that we created, A upon C, which is sine theta, B upon C, which is cos theta, and A upon B, which is tan theta, are known as the trigonometric ratios. So let's take a discussion forward of the trigonometric ratios. Now, in reference to the angle theta, the side opposite angle theta, which is the length BC, we can mark that as the opposite side. And the side right next to the angle theta, now there are two sides right next to it. One is the base, we call it the adjacent side. And the third side, which is to the right of angle theta, which is the longest side of the right triangle, is known as the hypotenuse. Okay, So the three ratios that we create, remember a trigonometric ratio is always in reference to a particular angle in a right triangle. So the first trigonometric ratio is sine, S-I-N, which is short for S-I-N-E, sine theta, is equal to the ratio between the length of the opposite side and the hypotenuse. I'm just going to write HYP for short. And the second ratio, cos of theta, is equal to the ratio between the length of the adjacent side, which is the base in this case, and the hypotenuse. And the third ratio, which is tan theta, is equal to the ratio between the opposite side and the adjacent side. Okay, so sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, and tan is opposite upon adjacent. So remember this short little mnemonic, SOHCHTOA, S-O-H-C-A-H-T-O-A. Sine is opposite over hypotenuse, cos is adjacent upon hypotenuse, and tan is opposite upon adjacent. Tan can also be found as the ratio between sine theta and cos theta. That's also another useful shortcut finding the tan of a particular angle. Now let's consider this triangle that I've made here, which has the angle theta and three sides. The length of BC is 6, the length of AC is 8, and the length of AB, which is the hypotenuse, is 10. And the question says, what is the value of sine theta? Now think about it. It was so. Sine is opposite upon hypotenuse. So which side is opposite theta? That's right. That's 6. And what's the length of the hypotenuse? 10. Correct. So sine theta is 6 upon 10. Similarly, what is cos theta? That is the length of the adjacent side, which is the base, 8, and the length of the hypotenuse, which is 10. And what is tan theta? So tan theta is equal to the ratio between the opposite and the adjacent, the TOA. So that's going to be 6 over 8. Okay, I hope you've figured this out. I'll give you another triangle and I want you to figure out the trigonometric ratios on your own. Consider this new triangle that I've made here. Try finding out all the three trigonometric ratios for this particular triangle. Hit the pause button right now and calculate the values on your own. Right. I'm going to put the small mnemonic here to help you remember what the formulas are, what the ratios are. So sine is opposite upon hypotenuse. That would be 5 over 13. Cos is adjacent upon hypotenuse. That would be 12 upon 13. And tan is opposite upon adjacent. That would be 5 upon 12. So remember this, very useful. Okay, this ends part 1 of basic trigonometry. I'll see you now in part 2.